Welcome to my video course on mastering ERTMS ETCS signaling systems. Today we're focusing on one of the most vital yet kind of unsung heroes of the entire Trackside architecture. We're talking about the LEU, the Lineside Electronics Unit. It's just a brilliant piece of engineering working totally silently behind the scenes to keep modern railways running smoothly. Let's get right into it. Picture this. A high-speed train is hurtling down a track at, say, 300 kilometers per hour. At that kind of insane speed, human eyes and traditional traffic lights out on the side of the tracks, they just don't cut it. The sheer physics of stopping a massive train means the driver and the onboard computers need to know exactly what's happening kilometers down the line, in absolute real time. To operate safely, you have to instantly transmit trackside signal statuses right into the cab of that high-speed train, without a single millisecond of delay. Bridging that physical gap between a static track infrastructure and a train moving faster than a race car, well, that's a massive engineering challenge, and it's exactly what we're going to unpack today. Here's our quick roadmap for today. 1. The trackside subsystem. 2. Introducing the LEU. 3. The signal journey. 4. Transmitting the telegram. And 5. Our conclusion.
All right, Section 1, the trackside subsystem.
The trackside subsystem is this incredibly rich, highly complex ecosystem of interconnected components. You've got your interlocking, or IXL, which makes those fundamental ground-level safety decisions about train routes. Then there's the radio block center, the RBC, safely managing all the trains in a specific area using continuous radio signals. We've got the NTG acting as a crucial network gateway, and the KMS managing cryptographic keys, so every piece of communication is perfectly secure from interference. Out on the physical track itself, you'll find Eurobalises, these robust transponders placed right between the steel rails. There are marker boards acting as visual reference points. And of course, our main focus for today, the LEU. I know, it sounds like a massive alphabet soup, but all these parts absolutely must work in perfect, seamless harmony. They form this invisible safety net, designed to keep trains safely separated, fully interoperable, and moving as efficiently as possible across entire continents.
Moving right along to Section 2, introducing the LEU.
So the LEU is formally defined as the safe equipment that interfaces between the interlocking, or sometimes other external trackside systems, and the switchable Eurobalises installed on the track. If you really want to grasp its core function, think of the LEU as a highly secure, lightning-fast translator. The interlocking speaks one specific language, dealing entirely with track occupancy, switch positions, and safe routes. But the speeding train needs to hear a completely different language. It needs specific movement authorities and exact speed limits. That's where the LEU comes in. It sits securely right in the middle, translating the interlocking's raw status into actionable digital messages that can be seamlessly passed to the train. Pretty cool, right?
Now, to really understand why the LEU is strictly necessary for this whole system to function, we've got to look at the two main types of Eurobalises out on the tracks. First, fixed Eurobalises. These are essentially electronic milestones. They're completely static, meaning they always transmit the exact same stored message, typically just telling a passing train its precise geographical location. They never change. Switchable Eurobalises, on the other hand, are totally dynamic. They're designed to transmit variable messages based on the real-time status of the track ahead, like whether a signal is clear or if there's a speed restriction coming up. But here's the catch. A switchable Eurobalise actually has no brain of its own, no way of knowing what the track status is. It relies entirely on the LEU to feed it the correct up-to-the-millisecond data. Without the LEU acting as its brain, that switchable Eurobalise would just sit there completely silent.
So what does this remarkable little unit actually do out in the field? First up, it continuously and securely receives signal statuses from the interlocking, and it handles this critical data with absolute mathematically proven fail-safe security. But its real power? That lies in its efficiency as a central hub. You see, a single LEU doesn't just manage one transponder. No, it can simultaneously interface with multiple switchable Eurobalises at once. As track conditions change, the LEU instantly evaluates the new raw status from the interlocking, consults its internal library of safe commands, and sends out suitable predefined ERTMS and ETCS messages to those specific balises. It's essentially orchestrating the data flow for an entire section of track, making sure every single balise is armed with the exact right message for the very next train that passes over.
Okay, Section 3, the signal journey.
Let's break this incredible process down into 4 distinct sequential steps to really visualize the journey of a signal. Step 1 begins deep within the infrastructure. The interlocking determines a safe route and generates a signal status. Let's say it confirms the next 5 kilometers of track are completely clear. Step 2, the LEU instantly receives this clear status information. Step 3 is where the magic translation actually happens. The LEU acts on this raw data by actively selecting and encoding a specific, predefined ETCS telegram. This telegram essentially translates to a digital command saying, proceed at maximum permitted speed. Finally, in Step 4, the LEU pushes that perfectly encoded telegram down the cables directly to this switchable Eurobalise. This arms it so it can transmit that command up to the train the very split second it passes over. The absolute crucial takeaway here is that the LEU is the vital, active bridge turning a static trackside decision into a dynamic, train-readable command.
Which brings us to Section 4, transmitting the telegram.
To actually cross that physical gap between the track and the train, the data has to be packaged perfectly. The LEU packages the raw data into a highly specialized format known as the ERTMS/ETCS language. The specific pieces of applicative data exchanged between the trackside and the train are called telegrams. Now, these telegrams aren't just random strings of code, no way. They are meticulously structured using specific variables, packets, and messages, according to incredibly strict European standards. It is a massive engineering triumph. Why does this matter so much? Because by using this rigorous standard syntax, we ensure absolute interoperability. It literally means a high-speed train built in Germany can cross a border and flawlessly, instantly read a trackside LEU built by a completely different manufacturer in France. They speak the exact same digital language.
And here's exactly how that standardized language makes the physical jump across the air gap. Down on the track sleepers is our switchable Eurobalise, completely loaded up with its specific telegram by the LEU. As the train flies over at hundreds of kilometers per hour, the train's onboard antenna unit beams down a powerful magnetic telepowering signal. This magnetic field literally wakes up the passive Eurobalise on the track. In that exact fraction of a millisecond, the energized balise instantly fires back an uplink signal. It beams the ETCS telegram provided by the LEU straight upward, cutting right through the air directly into the train's onboard computer. It is a flawless exchange of critical safety data happening way faster than the blink of an eye. Truly amazing stuff.
Finally, Section 5, conclusion and next steps. I want to leave you with a final, provocative thought to consider. Think about the unforgiving physical realities of modern high-speed rail. When a train is moving so unbelievably fast that human eyes can't even process trackside signals, how does this continuous, localized stream of translated data from the LEU ensure our safety? Well, the answer lies in the sheer perfection of the system. The LEU entirely removes the fragile human element from signal observation. It replaces it with a flawless, instantaneous, and mathematically proven stream of digital telegrams that command the train's braking systems directly. It is literally the invisible, unbreakable tether, keeping millions of passengers perfectly safe every single day.
Thanks, we're going to see you in next week.